Welcome to another session of UGC Net PYQ discussion class. Let's look into the first question. Which of the following are applications of symbol table? Option A, storage allocation. Option B, checking type compatibility. Option C, suppressing duplicate error messages. From this, you have to choose which are the applications of symbol table. First, I will give you a brief idea about what is symbol table. A symbol table is nothing but a component of a compiler. Actually, you can see a symbol table here. I will show a phases of a compiler. These are the phases of a compiler. What is a compiler? Compiler is nothing but a translator. That is when high level language is converted into lower machine level languages. For that purpose, we are using compiler. That is the function of a compiler. And a compiler has this around six phases: those lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, code generator. Apart from that, you can see a symbol table here and an error handler. The symbol table is actually storing whole program. Actually, symbol table is used to store the whole program, and these lexical analyzer, syntax analyzer, semantic analyzer, in the each step, these all the steps using the symbol table. Okay, because in this symbol table they are storing variables, function, procedure, whatever the things we are used in a program, those content are stored in the symbol table manager, and it has some special role. Symbol table has some special role, that is uh, actually compiler has a this symbol table as special data structure. Compiler is using this data structure for storing information about identifiers appearing in a source program. Okay, identifiers appear in a source program, and the main purpose, that is, it is used to store variables, procedures, functions, defined constant, labels, structures, file identification, compiler generated temporaries. These are all the data we can find out in symbol table. And each and every phase, that is lexical analyzer, semantic analyzer, those are all using this symbol table to access data as per whatever the data stored in the symbol table, that is used by the different phases of a compiler. And let's analyze the each and every statement given in the question. The first statement is given that suggest storage allocation is an application of a symbol table. That is storage allocation. That is what the definition of symbol table. Symbol table is used to store the whole program, that is variable and its scope and its sometimes its memory size or address. So this option E statement is true. Okay. Next, checking the type compatibility. That is also another application of symbol table, because during semantic analyzer, the compiler needs to ensure that operations are performed on compatible data types. For example, adding an integer to a string might be invalid in many languages. That is, in a one language, we can possible to add integer to a string, but in some many languages, it's not possible to adding an integer value to a string value. It's not possible. So the compiler should generate an error. So the checking type compatibility is another application of a symbol table, and this should result in an error. This should report an error actually. This type compatibility is generated there, means it should generate a type error. Okay. Next. Next statement, what they are suppressing duplicate error messages. That is, suppressing duplicate error messages means when Passing source code, the compiler might encounter multiple instances of the same error related to a specific symbol, such as multiple uses of an undeclared variable after the first occurrence, or attempting to declare a variable that has already been declared multiple times in the same scope. The symbol table can be used to keep track of which symbols have already caused a specific type of error or have been reported. By checking the symbol table, the compiler can avoid generating repetitive error messages for the same issue concerning the same identifier, making the error output cleaner and more helpful. What are they mentioning? That if we are declaring one variable like in the A we already declared. Similarly, again we are declaring same variable name in the A. So compiler will be confused why it should generate error. Which A will take, the first one or second one? There is a confusion will generated. To avoid this, it will check the symbol table and it will generate an error message. Okay, so this errors are suppressing. Actually, the compiler suppressing the duplicate error messages. And also the undeclared variables means if we are not declared the variable, if first we are declaring variable A, integer A, but we are printing the statement. If we are printing the statement that, see, I will int A we declared, but we are printing the statement in front of we are printing variable B. Okay, printing variable B. This should also generate error. So this type of undeclared variable here we can see. So this kind of errors also be identified by the compiler and it is suppressing. The error is suppressed by the compiler. So same issues are repeating in another segment or another area, so it will be suppressed. So in this question, we are concluding that option D is the correct answer. Okay, these three are the three statements given are the applications of symbol table. Next, move into another question. This is a simplified expression for the following Boolean function. See, here one function is given and find out which are the uh, expressions given are the correct as per this function. Okay, we are using K-map for solving this Boolean function. Okay, this is a basic for variable K-map I have displayed here. I hope you all know the basic idea about a K-map, how the values are arranging in the K-map. Here starting in a four variable K-map, you can accommodate up to 0 to 15. That is total 16 values we can accommodate in a K-map, four variable K-map. Here the value is arranging in a different manner. That is 0, the first column. See, we are starting from here 0, then 1. We can't put 2 here. The last end we are putting the 2. Then 3. Again 4, 5, 6, 7. This one column, the third column, you should left and right at the end. Likewise, here also, from third row, you should here this third here you should leave this column and write the values 2 here. And at same way, you have to left this row and write first fill this last row and then jump into third row. Okay, like this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then 12, 13, 14, 15. Likewise, we are writing the values in a K-map. Again, here also I have given some values. This is nothing but the 4 variable, that is values, that is 0, 0, 0, 1, 1, 0, 1, 1. Likewise, how the Boolean variables we can represent in a K-map. Same way 0, 0, 0, 1, 1, 0, 1, 1 we are writing here. Okay, moving to next. This is the solution for this question. Here I have given that we are grouping which are the data they given, which are the data they have given 0, 1, 2, 3, 6, 12, 13, 14, 15. As per these boxes, we are already arranged those values in the K-map. Wherever we can find out those values, we put 1 over there. Okay, 0th box, we will put 1, and first box, the 1 number where we can see the number 1, here we put 1. This is 1, and see one more value, then 2. Where is 2? You can find here. We put 1, and 3. Where is the value 3? Here we put 1. Then 6. Value 6 is here. We put 1. Then 12. Here also we put 1. 13, 14, 15. And we have to group these ones as per some rules. That is, we can group either values, two values, 2 ones, or 4 ones, or 8 ones. Okay, 4 ones we can group. Okay, 8 ones we can group. Here the we can't find out 8 ones, so the next value is 4 ones. So we group 4 ones first here, and again here 4 ones are all together. We group this box also. Then we have the option, either we can group 2 ones here, otherwise we can group ones below the 1. This way we can group. Okay, so that we will get 2 solution for this Boolean function. Okay, the first one, the first box, that is first group 1, what is the values we will get? We should identify which are the terms common. Here in this row, 0, 0 is common. That is A, here we can see that A bar, A bar, B bar. Okay. Here A bar, B bar is common. Similarly, you can see here 1, 1. That means A, B. A, B is common here. So we will, this row we will get the value AB, and this row we will get A bar, B bar. But here one column is, that is 1, 1. This value how we can take? Here common values are these. Common values are 1, 0, and left hand side you can see 0, 0 is common. The 0 is common. So how we can write? This is C D bar. Okay, C D bar is this. So that we wrote here. C D bar is already there. Then A bar. A bar means the 0 value. That is A bar. A bar. So this value we get. Then here the same equation, only one change we can see. This two ones are grouped down. So this value only change in this row. We will get this same value, and this row is same, and but this value is not same. Only the variable b is changed because here down we will get the common value b. Okay, b is common. So we will write a b here. So the answer is we get two options here. Two options here, that is AB plus A bar B bar plus A bar C D bar, AB plus A bar B bar plus B C D bar. Okay, this is the answer for this question. I hope this is clear. Next, move into another question. Which of the following statements with respect to K-segment pipelining are true? The option A, maximum speedup that a pipeline can provide is K theoretically. It is impossible to achieve maximum speedup K in K-segment pipeline. All segments in pipeline take same time in computation. That is, this is the question regarding pipelining. These three statements we have to analyze first. Okay. First statement, that is what is K-segment pipelining? That is a technique used in computer architecture to improve the throughput of a processor by dividing the instruction execution into a sequence of smaller steps or segments and overlapping the execution of multiple instruction. That is K-segment pipelining means we are dividing a process into sub-process and doing that process in a single step, smaller steps as a sequence. So we can, so that we can improve the performance of the processor. Okay. The first statement is given that maximum speedup that a pipeline can provide is K theoretically. That this is what the first statement they have given, that is we can provide maximum speed up K theoretically. This is true because in an ideal K segment pipeline each segment takes approximately the same amount of time because we are dividing a process into sub process. So each process, that is P1, P2, P3 are taking approximately the same amount of time to done that task. Okay, but in a non-pipelined execution take time T0 for one instruction and each of the K segments in the pipeline takes time TP by T0 divided by K. That is nothing but in non-pipelining, if one instruction is taking 0 time means first one instruction should complete first, then only another one can do. But in non-pipelining, all the instructions can do execution at a time. Each segment can process at a time, but each take a approximately same amount of time. That is, we can achieve theoretically, but in real world scenario, it is not possible. Okay. See here one equation given that is pipelined segment. This is pipelined segment. This is non-pipelined segment. So speed up how we can show that. We can theoretically prove that K we will get maximum speed up that a pipeline can provide is K, where K is the number of segments in the pipeline. Okay. But in this statement is also true, but next statement. Here it is impossible to achieve maximum speed of K in K segment pipelining. That is what I already mentioned that we can theoretically or equation wise we can prove that we can achieve K speed up in pipelining concept, but it is not possible to achieve maximum speed up in K in real world scenario. Okay, because some factors affecting its performance. Actually, speed up means efficiency into K. This efficiency always should reach 1. If efficiency is 1, then only we can get the speed up K. But this efficiency is affected by several factors that prevent ideal performance of the processor. Which are they? The factors affecting the performance is the segment delay, unequal segment times, setup clock or skew pipeline hazards. These are the factors affected by the uh, speed of the processor. So we can't achieve maximum speed of K in K segment pipeline. So this statement is also true. But in statement 3, all segments in pipeline take same time in computation. This is wrong because I already mentioned that if one process we are dividing into multiple sub process. Okay, that is segment wise we are doing. See some, for example, if we are one segment is doing instruction fetch and another segment is doing decoding and executing, different processor are processing are doing there. But they are taking not a, not every task cannot be completed in same amount of time. So each will take different time so that we can't say that all segments in pipeline take same time in computation. No, it's not true. Computation will take different time for different segment. Okay. So option C is wrong. So the correct answer is A and B only. Moving into another question, which of the following statements with respect to multi-processor system are true? That is given that related facts about multiprocessor. Option A, multiprocessor system is controlled by one operating system. In multiprocessor system, multiple computers are connected by the means of communication lines. Multiprocessor system is classified as multiple instruction stream and multiple data stream. These are the statements given regarding multiprocessor. So which are the statements are true? We have to identify from this. Okay, first I will give you a brief idea about multiprocessor. This is the pictorial representation of a multiprocessor system. In this, you can see a main memory as common, but multiple processor. The word multiprocessor means multiple processors or more processors can do the task. Multiple processor we can accommodate CPU 1, CPU 2, or CPU up to CPU n we can accommodate. Okay. See, the multiprocessor system is a computer system with two or more central processing unit, that is CPU, that share common access to main memory and peripherals. That is what I represented in this picture. You can see multiple CPUs are arranged here and different IO processor, IO units are there. They can access common memory together. Okay. This CPU is accessing this main memory and the second CPU is also accessing the main memory. Okay, first statement what they are telling that multiprocessor system is controlled by one operating system. Let's check what in a tightly coupled multiprocessor system. Multiprocessors share memory and are controlled by a single instance of the operating system. What they are telling, single instance of the operating system, that is tightly coupled multiprocessor. They are using the single instance of the operating system, so that the option A is true. That is the SOS manages scheduling of process threads across the available processes, resources allocation and inter-process communication, so that we can consider option A as true. Okay, next statement what they are given that in a multiprocessor system, multiple computers are connected by the means of communication lines. See in this picture, can you able to see multiple computers are connected is there? No, we can't tell that multiple is there any communication line and some many computers are connected here. No, it's wrong. It is not. That concept is coming under distributed systems. In distributed system only, we are using multiple computers. Okay, multiple computers, that is related, this statement is related to actually a distributed system, but in multiprocessor system typically share a single physical memory space and a system base. So this option B is wrong. Okay, option B is wrong. Next statement C, multiprocessor system is classified as multiple instruction stream and a multiple data stream. That is true. That is, this is a classification of Flyn's taxonomy. MIMD is the classification coming under Flyn's taxonomy. And in this, a MIMD, that is multiple instruction, multiple data stream system, is characterized by having multiple processors that can simultaneously execute different instructions on different data sets. That is what is meaning by this. Simultaneously, you can execute instruction and on different data set. Okay. Multiple processor system where each processor fetches its own instructions and operates on different parts of shared or private data falls under the MIMD category. Okay. Next, this is a short description of what is the Flyn's taxonomy. In this, we can see four types of classification, that is SISD, SIMD, MISD, MIMD. SISD, that is nothing but a single instruction, single data. That is traditional, we are using in this in traditional uniprocessor system, that is single instruction, the single data. SIMD means single instruction but multiple data, that we are used in vector processor and array processor. MISD is multiple instruction, single data. Okay, this the kind of architecture we can see in pipelining architecture. But in MIMD, multiple instruction, multiple data, that is we are used in multi-processor system, multi-core processor and a distributed system. So in this question, option B is wrong and option statement B is wrong. Okay. Next, which of the following statements regarding XML is true? This is question-based web technology question. Some of the statements given regarding XML. The option A is XML is a set of tags designed to tell browsers how to display text and images in a web page. And option B, XML defines a syntax for representing data, but the meaning of data varies from application to application. And option C, here small alphabets are used a letter, and here fully capitalized letter they have given, and the letter small and there are three different tags in XML. These are the three representation tags. They are telling that these three different tags are different in XML. Choose the correct answer from the given below. Okay, first I will give you a brief idea about what is XML and XML is a set of, actually XML is what, extensible markup language. Actually, its primary purpose is to define, store and transport data. XML is not designed to display data. Okay, here the statement what is saying, XML is a set of tags designed to tell browser how to display text. So this is wrong. That is not the purpose of XML. That is actually HTML tags are using. For that purpose, we are using HTML tag. How the text should be displayed in a web page, like in that purpose is done by HTML. But XML is used to define, store, and transport data. Okay. Here, hypertext markup language is the language specifically designed to display data and control the presentation of content, text, images in web browser using predefined tags. So the statement 1 is false. Next statement, XML syntax and data. XML defines a syntax for representing data, but the meaning of data varies from application to application. That is true. See, that is XML provides rules for structuring data using tags, attributes, and elements. This is it. That is It's index actually. For example, you can define tags like book, author, title, etc. The structure defined by XML syntax. So XML itself does not define what a book or an author inherently means. This is a special meaning in XML. Okay, and application processing XML data decides how to interpret and use the data associated with these tags. These different tags have different meaning. Okay, then not similar in real meaning. The XML defined tags have its own meaning. In two different application might use the same XML structure but assign different meanings or processes the data differently. If that is, in one application we are using date for one purpose, and in another application we are using date for another purpose. If we are using date in publication, but in another last updated date, we can use it as the same date. So this statement is true. That is, meaning of data varies from application to application. That is true. Okay. The last option is XML is case sensitive. That is also true because XML is a case sensitive language. This means that capitalization tag names matter. Capitalization that is different, and each these three tags are different. Okay. So answer option C is also true. So from this you can say that which is the correct option. These three are true actually. This A is wrong, B is true, C is true. So B and C only. B and C only. The answer is option C. I hope this class is clear for you. Thank you for watching.